Okay, let's learn more about equations. So in each list of numbers, find the one that solves the equation. So we're going to go to the first equation. This marker's no good anymore. Okay, so we got 1x minus 20 equals 12. And here are our choices, 32, 8, and 20. Okay, so we got to see which one solves that equation. So we could start by taking the first number, or actually you could start using a little common sense, okay? But because if we use 8, 8 minus 20 is not going to give me 12. 20 minus 20 is not going to give me 12. 32 actually is. I can do this one in my head. 32 minus 20 equals 12. This is 12 equals 12. So which one solves it? It is this one, 32. Let's look at number 2. Number 2 says negative 6 plus y equals 0. Oh, much better marker. Negative 6, 6, 0. Okay, here's the deal. I can try to push all of these in here and substitute them, or I can use a little common sense. We know opposites have a sum of 0. So this must be the opposite. So the opposite of negative 6 is 6. But if you didn't see that, I can just check that. Negative 6 plus 6 equals 0, and that does check. Okay? So the answer here is 6. Now what I'm going to ask you to do is use a little mental math on the next couple of problems in your workbook. Okay. You're not always going to get answers, possible answers for your equations. You're going to have to solve them yourself. Some of these are really easy. Some of them may not be so easy. But just let's take a look. This says some number plus 3 is going to give me 5. That's an easy one because we know 2 plus 3 is 5, so x is 2. That is the solution to that problem. And we just solved it. Okay, because we found an answer, a number that when you plugged it in, it made a true statement. Let's look at number 2. Something minus 4 equals 9. Well, that means it's got to be bigger than 9. In fact, it's got to be 4 bigger than 9 if you think about it. So y is 13 because 13 minus 4 will give me back 9. So that's the solution to that equation. Now this one. Well, there's a negative 5 plus b equals 2. If you think about this, this number, remember you owe somebody money, this number has to be bigger than 5 by 2 so that you have money. So this number has to be 7. I owe 5, I have 7, I have 2. So b equals 7. Okay. So these are pretty simple. And when we can do them in our heads, you probably should. But let's take a look at this next problem. Same thing we want to do. We want to solve this. So let's look at 176x plus 83 equals 7,200. Well, this is a little different. This might be a little hard to do in your head. You might need a little hand here. So I'm going to show you a way to solve equations without doing them in your head. Let's first talk about linear equations. In a linear equation, what it means to be linear, it means that linear equation in one variable we're going to solve today. Linear equation in one variable means you have one variable. Could be x, could be y, could be b, doesn't matter. But the exponent on that variable is a 1. That's one of the things that makes it linear. When we solve linear equations, the object is to get the variable on one side equal to the number on the other. A lot of people teach this a lot of different ways. If you know a way that works, fine. If you're not sure about a way, you may want to do it the way we're going to do it in class. Okay, but that is the goal, to get the variables on one side and the number on the other. So let's take a look. No, I'm not going to solve this now. It's too hard. All right. First of all, you have to understand we're going to solve this. And I know you can do this in your head. We're not going to right now. You have to understand an equation is like a scale and balance. I swear that I went all over town looking for scale so I could do this for you. All right, so I'm just going to have to kind of show you this. Think of this side of my head as being the equal sign. Okay, I usually put an equal sign on my head, but I don't really want to do that now. Okay, so I have a p plus 15 here and 23 here. Okay, because this says that this expression is equal to this expression. So I have p plus 15 on one side of my balance and 23 on the other. I'm a scale and balance. But I want to get, remember the goal, I want to get only p on this side and everything else on the other. So that means I got to get rid of this 15. The way to get rid of things attached to a variable is to do the opposite operation. The opposite operation of adding 15 would be to subtract 15. So I'm going to do the opposite operation. But if I do the opposite operation to that side, then watch what happens. If I have a scale and I subtract 15, and here's p plus 15, and I subtract 15, that means this side is getting less, but this side, well, I'm starting to tilt. So what do I have to do to this side to keep the scale in balance? And you better hurry up because I'm going to fall down. Well, if you subtract 15 on this side, then you have to subtract 15 on this side. So whatever you do to one side, you do to the other. And the reason for that is not because somebody told you to do that, because you have to keep the scale in balance. Now, here we go. This is just P. This is I have $15, I owe $15, that's 0. You don't really want to say cancel out. You don't cancel out numbers, you cancel checks. Okay, you don't cancel out numbers. Their sum is 0. I don't write the 0 unless it represents the entire side, and we'll talk about sides in a minute if I didn't say that enough. And now the equal comes down, and I have 23, I owe 15. So if I have 23 and I owe 15, I have 8. So the answer to this problem is 8. Okay? So we've accomplished the goal. Variables on one side, numbers on the other. Okay? Remember that whatever you do to one side, you do to the other to keep the scale in balance. Adding and subtracting will take terms from one side and bring them to the other. This equal sign separates the sides. P plus 15 is one side, 23 is the other. So whatever you did to one side, we did to the other. And there are some helpful tips in your notes that you can check. And we'll talk about them as we go along. So let's look at the, oh, you know what? Before I go to the next question, let me show you how you can check this. Because a lot of people redo the problem to check it. Okay, so here, let's try that. Okay, P plus 15 equals 23. Here's the check. There should be no algebra in the check. The check is just pure arithmetic. So P is 8, so I plug in 8. Okay, there's nothing to do on the right side, so leave it alone. Just do the entire left side. That's 23, and that equals 23. There's your check. So that's how we know we write. I'm going to be doing some checks, but not all the checks in all the problems we do. Let's take a look at some other problems. Let's look at number 1. Number 1 says a minus 6 equals negative 4. You probably know the answer to that, but we're going to work this out anyway. Remember the goal. Keep the goal in mind. Variables on one side, numbers on the other. And I'm going to show you some little tricks. I never move anything that's alone on one side. So see this negative 4? It's alone. I'm not going to touch him. I'm also not going to move anybody who doesn't have friends. What does that mean? That means I'm not going to move anybody who doesn't have a like term on the other side. So there's an A on this side. Sorry, there's an A on this side, but not an A on this side. So I'm not touching the A. So he's going. So I'm going to add 6. Why did I add 6? Because it's the opposite of subtraction. I'm going to add 6. A. This becomes 0. I can wipe it out. I don't have to write it. It doesn't represent a side. I bring the 0 down. I owe you 4. I have 6. So I have 2. So A equals 2. That should be your solution. We'll check it. A minus 6 equals negative 4. Wherever you see the A, you're going to put 2. 2 minus 6 equals negative 4. I'm going to keep that side alone. I'm just going to combine this. I have 2. I owe you 6, so I owe you 4. And that is correct, and that checks out. Let's notice this side. Number 2 is a little different. It's written backwards. Some people rewrite this. I wouldn't rewrite this. I would just understand the goal. If you just understand the goal, you can never get these wrong. That's the beauty of math. It's not like English where you could say it this way, you could say it that way, or some letters have no sounds. If there's other letters, I hate that. Okay, numbers are numbers. They're good. They're awesome. All the time the same. Okay, I'm not going to move the 12. He's alone. I'm not going to move the R because there's no R on that side. Okay, so I'm getting rid of the 2. How do I get rid of the 2? Well, I have to use the opposite operation. The opposite of addition is subtraction. But whatever I do to one side, I have to do to the other side of the equal. Think of the equal as a wall. I have to do to the other side, okay, to keep the scale in balance. I have 12. I owe you 2, so I have 10. And that equals R. Good night. So 10 equals R. And actually write it down exactly like that. However you see it, you should write it because later on when you solve inequalities, you don't want to mess around with one side of the equation and the other. So 10 is R, which is the same thing as R equals 10. Okay, so now we're going to check. Write down your original. This is pure arithmetic. Wherever you see an R, you're going to put in 10. So 12 equals 12, and that checks out. I'm not going to check all of these because we'll be here all day, but that's how the check goes. We'll solve the next 3. You try the next 3, and then we'll come back to them. And you can check them. I won't check them. Okay, number 3. Number 3 says y plus 6 equals 6. Remember the goal? Variable on one side, number on the other. I'm not going to touch him. He's alone. I'm not going to touch him. He's got no friends. All the variables are on the left. Leave them on the left. If all the variables are on the left, all the numbers have to come to the right. Okay? So subtract 6. Subtract 6. I subtracted because it's the opposite of addition, but whatever I do to this side, I got to do to this side of the equation. I put it under the like terms, numbers under numbers. So y, good night, equals, I have 6, I owe 6, I got nothing. Y equals 0. Okay? Let's try number 4. Negative 2 equals 4 plus x. Okay. Again, variables on one side, numbers on the other. I'm not going to touch him. He's alone. I'm solving for x. He's the only x. All the x's are on the right, so get all your numbers to the left. He's got no friends. I'm not touching him. I'm not moving him. He's got no friends on the other side. Poor guy. Must have just moved into town. Okay, so now I owe you 2. I owe you 4. So I owe you 6. And this goes. Because they're opposites, so x is negative 6, or negative 6 equals x. And very last one, a plus 7 equals 0. Okay, again, he's alone. I'm not going to touch him. He's got no friends on the other side. All the variables are on the left. Get all your numbers to the right. The opposite of addition is subtraction. A equals negative 7. Done. Okay, let's look at the next one. Let's see if we can make these any harder. They're a little too easy, huh? In your workbook, there are tons of rules on how to do this. Make sure you read them. You're allowed to read your workbook. That's kind of a good deal. All right, let's look at number 1. Number 1 says y plus 8 equals 3 minus 7. Okay, so let's take a look at that. Before you move anything, like we were moving things from one side to the other by the opposite operation, we have to clean up on one side. So let's look on the left side. And there are no like terms there, so we can't touch that side. There's nothing we can do with it. Now let's look at this side. On this side, there are things we can combine. So this is the first step, looking to see if we can combine the left side, and then looking to see if we can combine the right side. So we combine the right side by going, I have 3, I owe 7, so I owe 4. Now we can solve this just like we did before. Goal is variables on one side, numbers on the other. All the variables are already on the left, so get everything to the right. Again, I'm not going to touch him. He's alone. So I'm going to do the opposite of plus, which is subtract. We want to get the y alone, so I've got to get him out of there. Y equals, I owe 4, I owe 8, I owe 12. So y equals negative 12. I'm not going to check that, but you can. All right, so let's try this guy. Again, these are getting just a little harder. We want to see if we can combine anything here. We have like terms here, okay? So I owe you 4x, but I have 5x, so that's just x, or 1x. 1x or x, which is the same thing. You don't need to write that 1. Plus 8 equals negative 23. Now we get to solve it. All the variables are already on the left. Let's get the numbers to the right. So subtract 8, opposite operation, subtract 8. 1x equals, I owe you $23, I owe you $8, so I owe you $31. 1x is exactly the same as x, so there's nothing you have left to do. You are done. You don't even have to write this down. That's the same thing as that. You are done. Let me check that. But before I check that, I want you to compare these two equations to this third one. So I'm going to erase the answer here. And I'm going to erase all the work here, but I'm going to leave the answer because I want to check that for you in a minute. So let me compare these equations to this next one. 8x minus 5 equals 9x. Is this the same or different as these two? Let's take a look at that. Well, this one had like terms on this side. This one had like terms on the left side. This one has no like terms on the same side, but this does have variables on different sides. We're going to show you how to do this in a minute. And as long as you follow the goal, you're done. You're home free. You have to follow the goal. Okay? So here we go. Let me check that first, and then I'll do the problem. Remember, x is negative 31 here. And I'll rewrite this problem in a minute. I just don't want it to get in the way. So that next problem is different. Negative 31 is x. Here we go. Negative 4 times negative 31 plus 5 times negative 31 plus 8 equals negative 23. Okay, let's just do the left side. Now we're going to multiply this. Signs are the same, so it's going to be positive. This is a positive 124. This is a negative, because a positive times a negative, signs are different, is negative. Okay, 5 times 31 is 155, plus 8 equals negative 23. Now we got to think money, because I'm combining. I have 124, but I owe 155, so I'm going to have to subtract that. Okay, and when I subtract, just so you know, the bigger number always goes on top. It doesn't matter which number comes first. I have 124, but I owe you more money, so this is definitely going to be negative. I'm subtracting. You get 31. Negative 31 plus 8 equals negative. It's kind of like magic. I love this, the way that works out. It's just so cool. Okay. All right. What else could you be doing today? All right. I owe you 31. I have 8. I owe you 23. And this checks out. So it doesn't matter what the equation looks like. We can always do a check. Okay? Let's do that. Last one in your notebook on this page. Just to make sure you understand. If you know the goal, you know everything. Well, not everything in the whole world. But okay, let's look at that third problem that looked a little different. Don't let the way it looks make you crazy. Okay, remember the goal. The goal is variables on the one side, numbers on the other. But here's what I know. I know I don't want to touch him because he's alone on that side. If I touch him and move him, that means I have to put a 0 on that side. And if I do that, it's going to make another step. So I don't want to do that. You can do it. I'm not going to do that. Okay, so I'm not going to touch him, and I don't want to touch him. Do you know why I don't want to touch him? I don't want to touch him because he's got no friends on this side. He's got no pure numbers to combine with. So the only guy left to move is this. And he's a positive 8x. So I'm going to do the opposite of positive and make that negative 8x. Whatever I did on one side, I have to do the other to keep it in balance. Good night. Negative 5 equals, I have 9, I owe you 8, so I have 1x or just x. If you want to write the 1 there, you can. Either way, you are done. Let me do this check, and then I'm not going to check a whole lot more after this. Okay? So here's the check. Okay. 8x minus 5 equals 9x. And remember, x is negative 5. The reason I wanted to check this one is it's a little different. There's work on both sides. What I would do, so you don't get confused, is I would just do everything on the left side, then do everything on the right side, and pray for a good ending. Okay, here we go. 8 times negative 5 is negative 40. Because a positive times a negative is a negative, minus 5. Okay, so I owe you 40. I owe you 5. So I owe you 45. That is the left side. And now that's supposed to equal this side. 9 times negative 5 is negative 45. So that does check. We know we're right. If you got it wrong, you can't say, okay, it doesn't check, and move off. You have to find the number that solves this. So that means you try this problem again, or you check your check. Sometimes you make a mistake in your check. Okay, so that's the end of that problem. Let's go back to some really easy problems that we talked about earlier. All right. The first one is show with an example that 1x equals x. We said we knew that 1x equaled x because the multiplication property of 1 says whenever you multiply anything by 1, you get back the anything. Well, let's prove it to you. Let's say x is, oh, it doesn't matter. Anything you want. Let's say x is, okay, negative 64. I knew you'd pick that. Okay, so let's do it. X is negative 64. So 1 times negative 64 equals negative 64. Well, 1 times negative 64 is negative 64, which is equal to negative 64. That's going to check because it makes sense that it checks. 1 times anything is the anything. So you have to not just believe when I say these things. You have to know why they work. Don't just believe me. I'm from Brooklyn. Is negative x equal to negative 1x? Well, seems like it should be, okay? Because remember, there's always a number in front that you don't even see. So there's a 1 there. That would make them equal. But I could prove that to you too. Let's let x equals, okay, 5. Why 5? I have no idea. I also don't know why I picked negative 64 there. So what's the difference? Pick any number you want. Just don't pick a 0 or 1. That would be bad. Okay. All right. That's just negative 5. Negative times a positive. Signs are different. It's negative. 1 times 5 is 5. So that checks out. So yes, it says is it? And that is yes, it is equal. Number 3. I hope I'm going somewhere with these examples, because if I'm not, I don't know what I'm doing them for. I think I must be going somewhere. Okay, let's try these. Well, any number divided by itself is 1. 1 times 100 is 100. Checks out. Again, signs are the same, so it's positive. 8 divided by 8 is 1. 1 times negative 8 is negative 8. Checks out. Signs are different, makes my answer negative 60. Oops, I jumped the gun, but that's okay. Okay, 60 divided by 60 is 1, so my answer is negative 1. Again, I can check. Negative times a negative is a positive. 1 times 60 is 60. So where am I going with all of this? Well, let's take a look at this next one. 4x divided by 4, is that x? Okay, I want to know, is that x? Let's take a look. Well, we know anything divided by itself is 1. We may have a difference in sign, just make it negative 1. Well, here, I can do this. 4 divided by 4 is a 1, and I do get 1x or just x. Okay, I can show you that this works with a number. Let's let x equals 10. This is 4x divided by 4. Let's plug in x is 10. 4 times 10 divided by 4. That's 40 divided by 4. So x is 10. What did I just... Yep, so what did I just prove? Look, I almost forgot what I proved. Look, 4x divided by 4 is x. Look what I'm proving. 4x divided by 4 is x. I just proved it because 4x divided by 4 when x is 10 is 10. That's 10 when x is 10. And this is also 10 because x was 10. So I did prove it with a number. Okay? So 4x divided by 4 is x because I can just reduce that. Okay? All right. So how will that help me solve this next bunch of problems? Let's see if you can tell me. All right, you're going to solve these mentally. That means in your head. I'm going to explain what the first one means, and then you can do the other two. (3m equals 12). That means 3 times some number, m. 3 times some number equals 12. So if 3 times some number equals 12, that means that number has to be 4. There must be something in that erase. It keeps popping out of my hands. Okay, so m equals 4. Would you try 2 and 3? All right, so let's see what you did here. This says 6 times a number is negative 12. Well, if this is positive and we want a negative back, we know this has to be a negative. So x equals negative. 6 times what number will be 12? That would be 2. Because a positive times a negative is a negative. I can check this, and this is the last one I will check of this sort because this is new. 6x equals negative 12. 6 times negative 2 is negative 12, which is negative 12 equals negative 12. And that checks out. Let's look at this one. This says the opposite of a number equals 10. So the opposite of what number is 10? Well, the opposite of negative 10 is 10. Because this would be negative negative 10, which would be 10. Let me check this one just really quick because it's bothering me that I didn't pick this one to check. So let's do this one really quick. Remember, x is negative 10. Sine, two signs become positive. So it does check. Okay, so that's how you do it mentally, but it's not always a good idea to do these mentally because sometimes they're going to be bigger numbers. So let's take a look at some that we want you to, just to show you how to solve. Okay, so before I do this next set, I want to just say something about one problem. I'm going to make this problem up. It's not in your workbook. Okay, I just want to show you something. Okay. These numbers want to stay on here. Must be getting weaker. All right, if we have x plus 5 equals 12, the kind we just did today, remember how to do this problem. Variables on one side, numbers on the other. I have to do the opposite operation. So the opposite of adding 5 is subtracting 5. And I get x. That's 0. I don't want to write the 0. 12 minus 5 is 7. So I get x equals 7. What I want you to remember about this is, 1, you use the opposite operation, and 2, the only way to move from one side of the equals to the other side of the equals is to either do plus or minus. If you see a plus, you do minus. If you see a minus, you do plus. So addition and subtraction moves us from one side of the equal to the other. So let's take a look at this. I'm going to solve these. I'm not going to check these. Okay, you can check them yourselves. 4x equals 20. All right, variables on one side, numbers on the other. Okay, you already have that. So I'm not moving anything. So I'm not doing addition or subtraction because addition or subtraction moves. But here's the goal. The goal is we want our answer to be x equals something. The coefficient of x is 1. We need that coefficient to be a 1. Well, I need this coefficient to be a 1. We're always able to solve by doing the opposite operation. So this is being multiplied. The opposite operation is division. I'm going to write division like that. Please notice that I'm not using a different sign, and here's why I'm not using a different sign. I'm just using the opposite operation, and here's why. Because when I reduce this, a positive divided by a positive, if the signs are the same, that's the only way I'm going to get a positive 1x, which is what I want. That's positive 1x or just x. And 20 divided by 4 is 5, which makes sense because remember the original equation was 4x equals 20, and 4 times 5 is 20, so the answer is 5. So I'm doing the opposite operation, meaning division, but I'm keeping the sign because I'm still doing the opposite operation. I need the same sign so that I get a positive 1x back. So let's try the rest of these. (16 equals negative 2p). I'm going to do this one with you, and then I'm going to sneak over and do number 6, and then you can do the ones in between. Okay, number 2. Again, the goal, variables on one side, numbers on the other. I don't need to move anybody because I already have that. Variables on one side, numbers on the other. It doesn't matter which side I get them on. However, I need this coefficient of p to be a 1. This is attached by multiplication. The opposite of multiplication is division. So I need to divide. But I divide by exactly what's there. And I get a positive divided by a negative is a negative. 16 divided by 2 is 8. So negative 8 equals p. All right? Now let me do number 6 for you. And you're going to do 3, 4, and 5. Here's 6. 10 equals negative y. Okay. Well, variables are on one side, numbers on the other, but we're not done. We're not done because this says negative y. You could probably do this in your head, but I want to show you how to do it on paper. There's an actual number there that you don't see. That number is a 1. Because of that negative, it's a negative 1. So that's negative 1 times y. But now I have to get rid of the negative 1. It's attached by multiplication, so I divide by negative 1. And a positive divided by a negative is a negative. We get negative 10 equals y. So we're doing the same steps, just realizing let's see what the coefficient is so that we can do that problem. Okay, you try 3 through 5, and then I'll give you the answers to those. Okay, let's look at 3. 3 is negative 6 equals 6y, negative 6y. Okay, again, we're not moving anybody left or right, so we're not doing addition and subtraction. This is attached by multiplication. The opposite of multiplication is division. We're always getting rid of the number that's attached to the y. It just happens to be the same number here. Okay. Signs are the same. It's positive. 6 divided by 6 is 1. 1 equals, good night, that's a positive 1y. So 1 equals y. All right. Number 4, 1x equals 5. You're done. Because 1x is x. What could you do? You could divide by 1, but what happens when you divide by 1? You get back 5. So I wouldn't divide by 1. This is done. This is done. This is x equals 5. Same thing. So I'm done there. Number 5, last one. Negative x equals negative 40. I'm not done here because this was a positive 1. This is not a positive 1. This is a negative 1. I'm going to put that in there. The negative 1 is attached to the x by multiplication. I'm going to divide, because it's the opposite of multiplication, by exactly what's attached to the x. X equals, signs are the same, so it's positive. We get 40. Okay. All right, time to do some big problems. Here we go. Notice something. I want you to notice something. We are dividing here, but we're not dividing until all the variables are on one side and all the numbers are on the other. That's when we actually divide. That's going to be important in this next group of examples. All right, number 1. Number 2 is 15y plus 8 equals 16y. Okay, I'm going to give you a second just to do the first step. By that time, I'll be done writing, and you'll be done with the first step. All right, so let's take a look at this problem. And again, we want to have all the variables on one side, all the numbers on the other, and that's not cutting it here because that's not what's going on. Okay, well, I'm going to have to move a variable because the variables are not on the same side. So when I move, it means I'm going to add or subtract. So let's take a look at this. I'm not going to touch him. He's got no friends. I'm going to touch one of these. I'm not going to touch him because he's alone on that side. So he's going. That's a positive 10x, so I'm going to subtract 10x. But if I do it to this side, I got to do it to the other side to keep it in balance. So I have 11x's, but I owe you 10x's, so I have 1x or just x. Good night, because that's 0. They're opposites, and that equals negative 4. So x equals negative 4. And I'm not going to do the check. You can do the check. Okay? Let's take a look at this one. This one looks almost the same. I'm going to have to move a y, and that's what you should notice right at the get-go, because I have y's on both sides. I'm not going to touch him because he's alone. I'm going to touch this guy. Doesn't matter what side you get the variables on. Just make sure the variables on one side, numbers on the other. Okay, and we get 8 equals, I have 16 y's, I owe you 15 y's, so I have a y, and it's done. This is the hardest problem for most people, believe it or not. It looks like a really simple problem. Think about what you might want to do here. I'm going to give you a second to think about that, and my gut feeling is I know what you're going to do. Thinking? Sleeping? Now look at the person next to you and see if they got the same answer. Well, here we go. In order to do this problem, we have to have all the variables on one side and all the numbers on the other. We don't have the variables on one side. They're on opposite sides. I know a lot of you want to divide here because you see things attached by multiplication. That's not right. Okay? So you have to get rid of the x's. Doesn't matter which side I get the x's on. I like to move, if I have a choice, it doesn't matter if I move this x here or this x here because they all have friends. They're also all alone, but I have to move somebody because the variables have to be on one side, numbers have to be on the other. If I have a choice, my personal opinion is I'd like to get all the variables to the left, if I can. On this side, I didn't do that because I didn't want to move him because he was alone. So it just depends on the problem. If I have variables on both sides and numbers on both sides, or no numbers at all, I'm going to get the variables to this side. Don't memorize that. Just think about it. It doesn't matter where I move this, but I got to move them. Variables have to be on one side. So I have 7x's, but I owe you 10, so I owe you 3x's. But now that's equal to, this goes. That's 0 because they're opposites. You must write the 0 because it represents a side. But now we have a problem because we're not done. Okay? We're not done because this is just not x. This is negative 3 times x, so I have to get rid of that negative 3. Okay? So I'm going to divide by negative 3 because it's attached by multiplication. And we know 0 divided by anything is 0. So that was like a fun problem. That's one of my favorite problems because it looks so easy, but it's not as easy as it looks. Okay, so let's take everything we learned and kind of try to put it all together. To do that, I'm going to do this next problem, which says, write the following problem in symbols and then solve it. Okay, it says a number increased by 5 is 23. Okay, so in order to do that problem, I keep losing my eraser. It's okay. All right. I'm going to write this down because I really need to show you this word for word. Okay, here's what it says. It says a number increased by 5 is 23. Okay. This is really important. You have a list of words in your workbook that for all the keywords, for addition, subtraction, multiplication, division, and equals. Okay? So, if we have equals, there's a couple of different words that mean equal. One word that means equal is. That's the big time word. The result is, or just is. Gives is another keyword, and they're all in your workbook. Yields is another keyword. Amounts to is another keyword. Are, was, were, all the to-be verbs that I'm not really going to tell you what they are because I don't really know what all the to-be verbs are. But is, are, was, were, okay, yields is not a to-be verb, but it does mean is. Okay, so increase by is a key phrase, and so is. So a number, we'll call it x. You don't have to make it an x. I personally like x's. Increase by, remember, means plus. 5 is that equals 23. So let's solve this. Well, all the variables have to be on one side, numbers on the other. So I'm going to do the opposite of adding 5, which is subtracting 5. X, those are opposites. That reduces to 0, equals 18. So x is 18 is our answer. Now, here's what you can't do to check this. I'm going to erase this so I have more room on the board, but I want to show you something. This is the biggest error you can make, and some textbooks actually do this. Okay, it is absolutely wrong. Okay, the equation was x plus 5 equals 23, and the answer was 18. You cannot take this and plug it into there, and here's why. You wrote that equation. You might have wrote the wrong equation. And your answer might solve your equation, but it might not solve the words. Remember what the word said. The word said a number increased by 5 is 23. That's what the words say. You have to check the answer in the given problem. The given problem in this problem were the words. So you must check it in the words. A number increased by 5 is 23. That is correct. That is your check. That's it. Don't plug it in here. Let me show you why. Okay. You might write the wrong equation, but so your answer for your equation would solve your equation, but it would not solve the words of the problem. So never, ever, 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 ever check in what you write. You have to check in the original, and the original is the words. So make sure you're checking in the words and not what you write, because the words is the original. Okay? So let's try another one. Okay. Number 2. Negative 18 subtracted from, and this is all in your workbook, but I need to write this so you can see how we're getting it, is 64. All right, let's circle the keywords or phrases. Subtracted from is. Remember, whatever comes after the word from goes first. So a number goes first. You're subtracting negative 18. I'm going to use parentheses because I don't want to have a sign like that, is 64. So I did everything on the left side of is first. Okay? Whatever comes after the word from went first. A number went first. Subtracted from, negative 18 equals 64. So that's what you have for that one. And now we have a sign. You have a sign, so remember 2 signs become 1. Signs are the same, that's a plus. Now we can solve that. We're going to subtract 18. Subtract 18. That's 6. 5 minus 1 is 4, so x is 46. So be very careful about the keywords. Be careful about the word from. Phrase less than switches the order. Okay? So let's do, you try 3 and 4, and then we'll do it together. All right, let's see how you did with these. A number increased by -5 is 1. Well, there's the is, there's your equal. We're going to do everything before the equal. So a number increased by -5. So here's your equal. A number increased by -5 is 1. That's how that looks. Rash. I'm having a rash right here. Sign, no sign. Signs are different, so the signs become negative. X minus 5 equals 1. Add 5 because the opposite of -5 is +5. Add 5. Or the opposite of subtraction is addition, however you want to say it. X is 6. Okay? So that's your answer. I'm going to do this one, and then I'll check this one. -8 multiplied by a number yields. There's the key. There's another key. This keyword means equals. Oh, let me guess what this keyword is. I think it means division. No, this keyword means, this keyword means multiply. -8 multiplied by a number yields -72. All right? All the variables are already on one side, numbers on the other, but now the problem is the coefficient of that variable has to be a 1. So I have to get this out of here. The opposite of dividing, the opposite of multiplying is dividing, so we're going to divide by -8. We're going to divide by exactly what's there. Because we were multiplying, we have to divide. That's the opposite. Good night. That reduces to a 1, so that's 1x, or just x, equals, the signs are the same. So a negative divided by negative is a +9. So the answer is +9. Let's check that out. Last check. Okay, on this last check, it says -8 multiplied by a number. So here's a check very quickly. -8 multiplied by a number, your number was 9. And that gives me -72, and there's your check. So that's correct. So just make sure you understand the keywords. Make sure you understand how to solve equations when you move and what you use to move. And the next lesson we're going to do is simplifying algebraic expressions.